All right, welcome back for our next lesson in our algebra unit. This lesson I'm going to title Translating Algebraic Expressions. So today we're going to be taking word phrases and turning them into algebraic expressions, or the reverse of that, taking algebraic expressions and writing out what that would look like in words, and then taking it a step further and bringing it to word problems. So the first thing that we're going to do, some things that you might want to write down, are some of the key words and phrases that have to do with each of the mathematical operations that we use: addition, subtraction, multiplication, and division. I'll just buzz through these each of these operations. You might want to take some time to pause and write down some of the keywords and phrases. Many of them are pretty familiar, but still good to have. So the first operation is addition, and some words and phrases that come to mind to me when I'm thinking about addition: things that I might see in a word problem: added to, plus, the sum of, more than, increased by, the total of, and the word and, like 6 and 7 together is 13. Those are words that represent addition in math. The next operation we've got is subtraction, and some words and phrases that come to mind to me. I have subtracted from and minus. Those are pretty obvious. The difference. Difference is a word that has to do with subtraction, the difference of something. Another thing is less than. 13 less than 20 is 7. Decreased by, if you're decreasing something. Fewer than, you're taking away. All of these things have to do with subtraction. Our next operation is multiplication. So I have fewer words on this list, but multiplied by and times, those are pretty obvious multiplication words. The product refers to multiplication. I wrote the word twice, but that could very easily be a couple other things like twice or triple, quadruple, doubling. All of those words have to do with multiplication. You might be able to think of some others, but those are my short multiplication list. And division, the last thing here, was even smaller. Divided by, the quotient of, you might want to add like split, break into. All of those things have to do with division. At this point in your math careers, I'd say you have a pretty good grasp of which words refer to which operation, but in case you need it, there they are. Let's go to our first example problems, though. These problems will have no algebra involved, meaning no variables. We're just going to be translating basic mathematical expressions. The first one here I've got says 8 fewer than 21. So what I'm looking for you to be able to do is take these words and turn it into an expression. Don't answer it. Don't get an actual answer. What would it look like as an expression? So numbers and operations. For this one, fewer than, to me, says subtraction. The easy wrong answer would be 8 minus 21. That's not right. It's 8 fewer than 21. 21 is what I'm starting with, and I want to go 8 fewer than that. So I'm taking 8 from 21. This would be the expression that represents this word phrase. All right. Another quick one, and then we'll get to the algebra. The product. So product means multiply. The reason I put this one on the screen is because there's a couple ways you might write this. You might write 30 and then the multiplication dot 9. Some of you might be saying, but I could do 30 and then put the 9 in parentheses, because when I've got a number directly next to parentheses, that means multiplication. This is another way to express this. And then you could also do the reverse of both of these, 9 times 30, or 9 and then parentheses 30. All of these would work for the product of 30 and 9. But on to the algebraic ones. Here we go. Write each phrase as an algebraic, there's that word, algebra expression, meaning not only should you have numbers and operations, you should also have variables. Variables represent unknown numbers. So in number 1, where it says 14 more than a number is, well, that's a variable because I don't know what the number is. So for a number, you could put X or A or C or Y or whatever variable you'd like, The words more than tell me that I'm going to be using the operation of addition, and then I've got this number 14. So if I put it all together, the algebraic expression would be 14 plus x, or a, or whatever letter you use. I'm most oftentimes going to use x. Another way to write this would be x plus 14. When you are adding numbers, the order doesn't matter. So 14 plus x, x plus 14 either would be fine. Let's try another one. A number, so you choose the variable for a number, I'll use x, minus 75. Couldn't make this one any easier. That would just be x minus 75 subtracted by 75. Now, whereas in number 1 you could write it two different ways, for number 2 you can't switch the order of a subtraction problem, so the only possible answer for this would be x minus 75. You cannot change that to 75 minus x. All right, I've got one more on the screen to try. The quotient of 3 and x. So I already am given the variable x. Quotient refers to division. And for division problems, when you're translating words into expressions, how do you know if it's 3 divided by x or x divided by 3? For division problems, you go from left to right. Whatever comes first is the first number in your division problem, and whatever comes second is the second number. So the only way that you would write number 3 properly would be 3 divided by x. And that's what this would look like. All right. Now we're going to build on this when we do practice problems. We'll be doing expressions that have multiple steps to them when you're translating them. For now, here's some basic one-steppers. I'm going to give you one two-stepper to try right now and type in your answer, and we'll see when we review this lesson how you do. All right, for this word problem example, it says the length of Interstate 90 from the west coast to the east coast is 153.5 miles more than 2 times the length of a different interstate, Interstate 15, which runs from California to Montana. And we're also told one other piece of information. It says let m, the variable m, represent the length of Interstate 15. So here's how we're going to approach this problem. First, if you're a visual person, here's a quick little sketch. This is the United States of America. I'm an artist. And we'll say this is California. And over here on the East Coast, here's us, New Jersey. And I'm going to use this green line to represent Interstate 90. So Interstate 90 runs the length of the West Coast to the East Coast. And I'm going to use a blue to go from California to Montana, which is, we'll pretend Montana's like right here, and this is Interstate 15. All right, the length of Interstate 90, the big one, is the same thing as doubling Interstate 15 and 153.5 miles more than that. Well, what does that look like as an algebraic expression? So first off, I'll pause and let you take a guess. Is it answer choice A, answer choice B, C, or D? All right, and now let's try to figure out which one it is and why it is that. I came up with this expression. Interstate 90, I'm going to use words. Interstate, or I'll use I-90 is equals 153.5 miles more, so plus, more than what? More than 2 times Interstate 15. So more than 2 times Interstate 15. Interstate 90 is, in other words, equals 153.5 more than plus whatever Interstate 15 is, double, 2 times that. So now let's just make this look a little bit cleaner. We were told that M represents the length of Interstate 15. So I'm going to take out I-15 and replace it with the variable m. So 2 times interstate 15, 2m, 153.5 miles more than that, so whatever that is, plus 153.5 more miles, that represents the length of interstate 90. So this expression is what interstate 90 is equal to. Double interstate 15, so double m, and 153.5 more than that, so plus 153.5. These problems at first aren't going to go perfectly for you, but the more word problems that you read and then translate, the easier it gets. So be patient. If this one didn't go perfectly or felt a little confusing, that's totally okay. We're going to do so many more of these, and I guarantee it will get better. The more that you practice, the more effort you put into these, the better it will get. One more example problem. Here we go. For this one, I'll read it, and then I want you to try to come up with an expression, and we'll see how you do. So you plant a cypress tree that's 10 inches tall. So it starts off as a little baby 10-inch tree, and every year its height increases by 15 inches. Part 1. Can you come up with an expression that could be used to represent the height after any number of years? And we're going to use the variable t to represent the number of years. Remember, the height increases by 15 inches each year. So see if you can come up with something. If you're not sure, you can write, I'm not sure, but give it a shot. All right, I came up with, you start at 10 inches tall, and every year your height increases, so it goes up adds by 15 inches each year. So 15 inches times, let's say we wanted to know how tall is this tree after a year. I could plug in 1 for the years. It grows 15 inches per year. Plus it was already 10 inches. That would give me the height after 1 year. If it was 2 years, I could plug in 2 for t, multiply that by 15, because 15 inches per year times 2 years would be 30, plus 10, 40 total inches. And in fact, I've got a question for you. What would the height of the tree be after 9 years? Give it a shot. So to evaluate this expression, I did 10 plus 15. And instead of t, I know what t is in this problem. We're told the number of years is 9. And t equals years, so 15 times 9. And using order of operations, I would do 15 times 9 first, which is 135. Plus 10, and I get 145, final answer. So the final answer for this would be 145 inches tall after 9 years, if it keeps growing at a rate of 15 inches per year. And with that, we're going to wrap up this lesson on translating algebraic expressions. Like I've already said, if it didn't feel perfect, that's okay. Especially with the word problems, it takes time and it takes practice. So the more that we do, the better you will get. We will be spending more time on this in class. So just come ready. If you have questions, please let me know what those are. If you don't feel comfortable asking them in class, please make sure you ask them on the video for this last question that pops up on the screen. Other than that, have a wonderful day, and I will see you in class later, Gators.